Hi, in this video, I'll be explaining about Chapter 6 from the textbook Transportation Management with SAP TM. So, first is transportation planning. So, this is very important for creating efficient transportation system. So, the main objective is to match transportation needs, which is actually represented by documents like orders and deliveries. So, with transportation capacities such as vehicles and containers, this can be actually done manually or automatically as well. So, this also aims to provide smooth planning transition between automation and manual intervention. Next is freight unit. So this actually represents transportable items that actually move together from their source to their destination. So these units actually simplify planning by actually grouping goods for transportation, which also ensures they remain together throughout the logistic process. And this image is the relationship of fleet units to other objects. So these are such as orders and deliveries. So one fleet unit can have multiple transport requirement, and one requirement may yield several fleet units, which also depends on the logistics scenario. So next is fleet units. The property of fleet units. Fleet units are customizable properties, which is defined by their type, which can influence aspects like tracking, shipment methods and organizational data. So they also provide details such as pickup and delivery window and the required capacities as well. So this figure actually shows how system calculates pickup and delivery windows, which also specifies acceptable and requested times for both pickup and delivery. So this time window actually helps to optimize transportation planning. And this interface is actually the freight unit user interface, which provides multiple tabs, which includes general data, items, business partners, and stage. This also allows users to view and manage freight unit details such as pickup and delivery information. And next is organizational interaction process. So this shows how different organizational unit within logistic provide and interact in handling how they handle a fleet unit. So this also highlights the responsibility of each department, which goes in planning and execution, which is part of the transportation process. Next is creating fleet units. So these are created based on business documents like orders and deliveries, either automatically or manually. So users can actually split or merge fleet units to adapt to capacity constraints which they have. And next is the trigger for fleet unit creation. So this is actually done through predecessor documents which explains when and how fleet units are generated based on various transport requirements they have. This image is the assignment. This image actually shows how items are assigned to fleet units, which also provides optimal solution based on constraints like volume and weight. So it compares optimal and best approach for the assignment. Uh, Next is the package building. So this is very important step where items in fleet units are grouped into package like pallets, which actually simplifies load planning and also ensures that vehicles are loaded more efficiently. And this figure actually shows the planning process from fleet unit creation to package building and load planning. So this also emphasizes the role of package building in optimizing how items are loaded onto the vehicle. Next is this image actually shows compares a fleet unit with the package building. Um, which is organized into pallets to one without it. This also shows how package building actually helps to streamline transportation by actually consolidating the items. So next image actually shows the master data which is required for package building, such as product dimensions and package assignment. This also shows how these elements are actually linked to create structured package for transportation. And next is transportation units, fleet units, fleet orders, and fleet booking. So while fleet units represent transport demand, transportation units actually combine demand and capacity. So fleet orders and booking actually represent the capacity, which is used to satisfy the transportation demand which arises. Um, Next is the trailer units. So this actually represents transport unit that actually require coupling to trucks on for the movement. So they are actually critical in truck trailer logistics, which also allows for flexible assignment between trailers and the trucks. And this is the image which actually shows different configuration of the trucks and trailers, which also explains how various units like full trailers and semi trailers can be attached onto the trucks for transport. And this is the fleet order map. This map actually shows how fleet orders, such as for roads transport, can be visualized geographically. So this shows the path and the stages of the trailer unit during the transportation. And next is a rail car unit. So this actually operates similarly to the trailer unit, but are actually used for rail transportation. So these units can actually assign to rail fleet orders and are very actually important for bulk logistics. Next is the container units. So these are actually specialized for carrying goods in containers, which may actually involve multiple transportation mode. So planning for container units actually requires empty container management and compatibility for various types of goods. And this is the image which shows the stages involved in moving container units. So this also shows how they are interact with various business documents like fleet orders and transportation units. And next is manual planning. So this involves creating and adjusting transportation plans interactively with the transportation cockpit. So this interface actually allows planners to manually assign a resource and routes and schedules. And next is the planning strategy. So this actually defines how steps should be taken during manual and automatic planning. So these strategies actually involve methods for vehicle routing, scheduling, and load optimizing. Next is selection profile and selection attributes. So selection profile define how transport documents are considered for planning. So attributes like time, geography, and specific condition actually used to filter and prioritize the fleet units. And this image actually shows the structure of selection profile, which highlights its building blocks like time-related attributes, geographical selection, and other specific attributes which are used during transportation planning. And next is planning profile and setting. So planning profile actually defines various parameters which control how transportation planning process is carried out. So these include capacity selection setting, optimizer setting, and load planning setting, and also cost planning and incompatibility settings. So planners can actually create or customize profiles which are actually based on our specific business needs, which with actually key elements like document type and time horizons for a fleet. And next we have the configuring the transportation cockpit. So this the transportation cockpit is very key interface for planning and monitoring transportation operations. So different planners and different planners and scenarios require specific information. So the cockpit is configurable. So the planners can actually define page layout, screen areas, charts, and a hierarchical view, which also ensures that only relevant data is actually displayed for efficient planning. So this image actually shows a cockpit setup with a map on the left, which also displays planned and unplanned fleet units on the right. So the show so on the right we can see the Gantt chart, which shows the planned fleet units in the upper part, while the truck utilization also is shown in the lower part. This layout actually is useful for fleet managers, which oversees transportation resources like trucks. And then the cockpit loading planning layout. This is designed for planners focusing on load details, where top screen area lists the road fleet orders, and bottom screen displays the load planning details. So this view actually helps to ensure pallets or items are arranged correctly within the vehicles according to weight and space constraints. And next is the hierarchical view and dual view. So the hierarchical view actually shows the structural relationship between transportation objects like fleet units and fleet orders. So dual view allows two different hierarchical view to be displayed simultaneously, which also enables planners to compare data across resource or orders for actually better planning decision. So these view can be particularly useful when optimizing fleet units assignment. Next is the trailer unit hierarchical view. So this figure presents a trailer unit hierarchical view where planners can actually drill down into substructures like stages and fleet units, which also helps in understanding the detailed movements of transportation units, which includes their cargo and actually routing. And next is the map. So the map feature in the transportation cockpit actually helps planners to focus on geographical aspects like planning, which allows them to visualize objects on the map and make decision based on proximity or route optimization. So this is particularly useful for decision around consolidation and capacity utilization. And this is an image which shows the use of map in planning. So it displays unplanned fleet units and a single planned fleet units, which helps planners to like identify available fleet that actually needs to be allocated to transport resources. And next is the load plan. So this organizes how items such as pallets are physically placed within transportation units. So this is essential for ensuring optimal use of space and for avoiding load imbalance. So the graphical view of the load plan actually helps planners to visualize the physical arrangement of the cargo. So this image actually shows the layout of the load plan in the cockpit, which has details about the position of the loaded items. So the load plan also includes items position, orientation, and other important physical characteristics such as weight distribution across the vehicle axis as well. And next is the transportation cockpit. This is the main interface of transportation planner. So it provides access to all transportation data, which allows manual and automated intervention in planning. So this is highly customizable, which offers various view like Gantt chart, maps, and hierarchical view to suit different types of transportation scenario. And next is the selection criteria. So this figure shows how planners can identify ad hoc selection criteria in the cockpit. Selection can also be based on fleet unit stages, transportation or fleet orders, and users can actually save or personalize these criteria for recurring tasks. And next is the how to use the transportation cockpit. So users can actually utilize the cockpit for various planning tasks such as assigning resources to fleet orders or adjusting delivery schedules. So this interface actually supports a variety of transportation modes and provides tool for drag and drop assignment of fleet units. And next is group fleet unit stage list. So this shows how a group view of fleet unit stage and organized are actually organized to streamline planning by allowing each identification of available or planned unit. So this actually helps planners manage and assign fleet units more effectively. And next is transportation proposal. So this feature automatically generates a potential transportation solution, which is actually based on predefined rules and optimizer setting. So planners can actually review or modify or accept these proposals to streamline their operation. And this image actually shows how the layout of transportation proposal gives the result, which also includes the map and this visualize the proposed route and fleet allocation. So this also provides planners with the intuitive view of how the proposed solution can be executed. And next is scheduling. So this actually refers to setting, picking, and delivery time for the fleet units. So the system can handle this automatically based on the predefined criteria, but manual adjustment also can be done whenever there is a need during the planning process. Next is the background planning and vehicle scheduling and routing. So this refers to automated scheduling and routing process that actually takes place behind the scenes, which is also triggered by defined parameters. So this also helps streamline large scale transportation planning and reduce manual intervention. Next is background planning. So this shows graphical representation of background planning process. This shows how tasks like vehicle scheduling and routing are executed without manual intervention. Next is configuring optimizer setting. So optimizer setting governs how the system generates transportation proposal and routes. So these settings actually allow for customizing or customization of cost consideration, time constraints, and other factors which also influence vehicle scheduling and route decision. And this is the optimizer setting, like the configuration interface for optimizer setting, where planners can define constraints and objective, which actually influence the optimization of transportation routes and schedule. And next is the vehicle scheduling and routing. So we have planning objective. So vehicle scheduling and routing actually aims to like minimize cost and maximize efficiency while also considering factors like distance, time, and load capacity. So the system also balances these objectives to like create optimal transportation plan. So this image actually shows constraint between two approaches to calculate costs. So one is destination based, focus on the endpoint, and route based, focus on the path taken. So this helps the planners to like decide which method is best for their business needs. So next is vehicle scheduling and routing, planning constraint. So planning constraints actually include factors like vehicle capacity, road restriction, and legal limitations. So these constraints actually ensures the transportation plan is feasible and complies with all the necessary regulations. And this image actually shows how capacity constraints like vehicle compartment limits and allowable vehicle combinations are factored into planning process to prevent overloading and incompatible assignments. Um, so next is vehicle scheduling and routing, which has optimization algorithm. So this algorithm process actually has various inputs such as constraint, objective, and available resource to actually generate the most efficient transportation plan. So with this continuously adjustable thing, based on changes in condition. And new orders, this continuously changes because this is a algorithm, and this image shows the VSR optimizer runtime behavior. So this behaves over time, adapting to changes in demand and resources while also maintaining efficiency. And next is the explanation tool. So this helps planners to understand why specific optimization decisions were made, providing transparency in the system's recommendation and allowing for better manual adjustment if necessary. So this image shows how input data is analyzed during the optimization process, which helps planners to review the parameters in decision making for better understanding and adjustment. Next is load optimization. So ensures that physical arrangement of items within the vehicle is efficient as possible, which minimize waste space while adhering to weight and size constraint. So this image shows the rules for load planning, including axle distribution, which also ensures the vehicle load is actually balanced and prevent overloading on any of the single axle. That's all for chapter 6. Thank you.